So now that we've walked through the API for AsyncTaskBarrier, and I showed you how you can use it to write a test program to exercise its features, let's take a deeper look at how we use RxJava operators that we've discussed to this point, like fromIterable, map, flatMapCompletable, toSingle, and so on, in order to actually implement the methods in the AsyncTaskBarrier framework. And you can see this is where the code actually resides. So let's take a look at this. So first of all, there's a private static field called sTasks. As you can see, it's a list of suppliers to completables. That's the signature that will be expected to register and unregister the various components, tasks in this AsyncTaskBarrier framework. And we initialize this to be a new empty array list. So pretty straightforward, pretty obvious. The register and unregister methods are super simple. All they do is add and or remove the registered tasks from that internal sTasks list. So you can see here what we're going to do is we're going to pass in a task, which is a supplier to a completable. Anything that matches that signature can be passed as a method reference here or a lambda expression. And this return type here, the completable, is important because that's what's used to signal to the AsyncTaskBarrier that's waiting in the run, or waiting for the signals to occur with the runTasks call in order for it to be notified when a task completes, either asynchronously or synchronously. So you have to return a completable, and then it's going to know it's done. And you can see all it does is it just adds it to the sTasks list or removes it. Very, very straightforward. Here's where the fun starts. So the runTasks method is what's used to run all of these registered tasks. And this actually took me some time to get right. It's very subtle, getting it to work properly. And I'm going to show it to you because it took me a while to figure it out, and it might come in handy for other things you may do at some point if you continue on with reactive programming with RxJava. It turns out that if you're doing this for Project Reactor, slightly different set of API calls because Project Reactor is somewhat different than RxJava, but same basic idea. So notice that this returns a single to a long, which will emit the number of tasks that completed successfully. What does it mean to complete successfully? It means that there wasn't an exception that was thrown. So let's go ahead and take a look and see how this works. So the first thing you notice is we take our list of registered tasks, the ones that were registered with suppliers to completables, and we convert that into an observable. So we use the fromIterable factory method to take the list of suppliers and turn it into an observable stream of suppliers. So far, so good. Next thing we're going to do is we're going to go ahead and run all the registered tasks. So this is kind of cool. Remember what happens fromIterable returns a stream of suppliers. And then for each supplier in the stream, the map method is called. And the map is going to call the get method of the supplier. So remember, when you use a supplier, you call get. And whatever the supplier is supposed to do, it'll then go ahead and do. And keep in mind that the method that's called could either run and return synchronously or could run asynchronously. In either case, you're ultimately going to get a completable back from it. Now, what's interesting here is if something goes wrong, what we're going to do is we're just going to swallow that exception, but we're also going to update something called an exception count. So if we look at the implementation of the error handler parameter to onErrorResumeNext, which I think is a function, we'll see that what it does is it takes the error handler function, and if this gets called back, in other words, if an exception is thrown, it will decrement the exception count. Exception count is essentially an atomic integer, or atomic long. I guess it's atomic long. And it'll decrement that count by 1. So that's what will happen if something goes wrong. If nothing goes wrong, if there's no exception, onErrorResumeNext will not be called. Note that onErrorResumeNext is a resumptive exception handler method. And what that means is it will go ahead and it's going to continue processing after first noting the fact that the exception occurred. All right, now we get to the most interesting part. So what has happened here is we've got ourselves a map call, and map is going to basically take in a supplier to a completable, and it's going to return a completable. So we're going to have a stream of completable objects. That's a little weird. And so what we do to manage this is we use another very useful operator in RxJava called flatMapCompletable, which is an operator on Observable. This also exists for Flowable as well. And what that does is it takes the completable and just basically absorbs it. And so what it's doing is it's mapping each element of the observable, which is now completables, into a so-called completable source. It subscribes to them, waits until the upstream and all completable sources complete, and then it returns a single completable. So flatMapCompletable returns a single completable, which is triggered only when all the other ones finish. So it's completely wacky and crazy. So this is going to give you back one completable that will be triggered when everything else is done. Very similar in spirit to the way that the all-of method works with Java completable futures, where you can have one completable future that comes back that is triggered when all the other things that were running asynchronously complete. OK, so we've now got one completable. And when that completes, then we're going to go ahead and convert this to a single. So we're going to convert the completable into a single. And then we're going to use that to figure out how many of the tests actually ran successfully. And we do that by taking the original size of the number of registered suppliers, which is the size of the sTasks list that we've been storing things into when we register them. And then we subtract from it the count of exceptions that occurred. That could be 0 if nobody threw an exception, or it'll be whatever it is. And that count is updated here when the onErrorResumeNext processing of the error handler, which is what updated that count. So that's how we're going to get back the final results for this. So that is basically a walkthrough of the implementation of the AsyncTaskBarrier framework. I find this framework very useful for all kinds of things. It's easy to take it and modify it as you see fit for other purposes you may have that don't quite work with the AsyncTaskBarrier interface. But now at least you know how you can wait for a bunch of things with a single to wait for the completion of the asynchronous or synchronous task.